Hello, welcome to the Getting Started with Hasura video. I'm Praveen, a developer advocate at Hasura. So let's look at what is Hasura. Hasura gives you instant real-time GraphQL for all your data. It comes with built-in authorization and caching so that it takes care of your permission layer and also performance. It's also open source. Let's look at how Hasura fits in the current app ecosystem. You have consumers of data like your web app or your mobile app, and you have producers like the databases and external APIs. Hasura becomes a self-serve API layer in the middle via GraphQL. So to make access to data self-serve, Hasura collapses three different layers into one. Let's look at what are those three layers. Typically, consumers access data by going through these layers. The first is the API gateway, which takes care of load balancing, the security, and rate limiting stuff. Then comes the app layer, which takes care of the authorization, caching, and so on. And then the ORM layer, which takes care of query compilation and then communicating with the database to get the data or insert back into the database. Hasura collapses all these three layers into one. It takes care of the N+1 query compilation, connection pooling, and database connections, and then replaces the entire ORM layer. It also takes care of the authorization and caching, and also sending business logic to events, and then replacing the entire app server layer. And finally, Hasura also takes care of load balancing, security, and rate limiting, thereby behaving as an API gateway for consumers to directly access. Now let's look at the data sources supported by Hasura. Hasura supports Postgres and Postgres flavors, SQL Server, and BigQuery. And it also supports REST APIs and any GraphQL API that can be added as a remote schema so that you can join data across any of these sources to become a unified GraphQL API. Support for more databases is coming soon. Now let's look at the key use cases for Hasura. Hasura works really well with existing databases, thereby enabling modernization of legacy data. And for new databases, it helps in rapid development of greenfield projects. Hasura can be used to replace direct DB access from client using the GraphQL API and creating a unified and a federated experience from the client-side app. Hasura reduces the total cost of ownership by bundling the three different infra layers like the API gateway, the app server, and the ORM layer into a single layer. So let's look at the agenda for today. We'll deploy Hasura and connect a database like Postgres. We'll leverage the power of the database and also set up some authorization rules so that you can make your app secure. All right, let's dive into the demo. I will go to the Hasura website and I'll click on login. So I'm going to start by deploying Hasura and I'm going to use Hasura Cloud for that. You can also use your local setup where you will have a Docker Compose setup for installing Hasura and Postgres together. But for ease of use and to not worry about infrastructure, I'm going to quickly make use of Hasura Cloud to create a new project. I'm going to click on new project on the dashboard and I'm going to use the free tier and I'm going to use the default region, and as the project name I'm going to say getting started. I'm going to click on create project. Now once the project is created, we'll have a GraphQL API that will be generated, and this is the GraphQL API endpoint we have. This is the app name that we gave, getting started.hasura.app and at v1/GraphQL. And the region being used is the US West, and we're on the free tier right now. So it's going to take a few seconds to initialize, and there you go. So all good on the status. I want to click on launch console. This is going to open up the Hasura console, and this is the UI where you will be managing the database connections, and we'll also explore the APIs that are generated and all the metadata around Hasura like actions and remote schemas and events. So this is the Hasura console for you. And the first step is to connect a database to Hasura. So we have Hasura deployed over here, but we don't have any database connected yet. So I'm going to start off by connecting a database, and we have two options. First option is to connect an existing database. So if you already have a Postgres database or a MS Server database, then you can obviously give in the credentials in the database URL over here and get started with it quickly. But for this particular demo, I'm going to make use of a Heroku database from scratch. So Heroku gives you like a free Postgres add-on, and we're going to make use of that. So I'm going to click on create database. This is going to create a brand new database for me, and Hasura is actually connecting to the Heroku Postgres connection string, right? So this is all happening in the background, and once this is initialized, you will get like a GraphQL API on top of Postgres that we've connected. And the data source has been added successfully. And if you look at the connected databases, you can see that there is a Heroku app Postgres that has been connected. Now let's head to the public schema of the Postgres database. Over here, I'm going to create a new table. So I'm going to define data models for my application. So I'm going to use a data model for like a real-time to-do app, which will have users table, to-dos table, and like a view to calculate the online users in real time. So to get started with, I'm going to create a table, and the table name would be users. It's going to have a few columns. I'm going to start off with the ID, which will be of type text. And I'm going to make use of the name column, which should be of type text again. And I'm going to make use of a frequently used column called created at, which is a timestamp. And I'm going to give it a default value now. And finally, I'm going to have a column called last seen, which will be also of type timestamp. And I'm going to keep it nullable because not every user will require a last seen column. And the primary key would be ID for the users table. And once you're done with that, I'm going to click on add table. All right, now table has been created. And if you look at the columns, we can see that the ID, name, created at, and last seen are available here. We can browse rows through this interface. We can modify data and set up some permissions. All right, to get started with, we'll go to the API. And on the left, if you look at, there is a user's query, and you can also add a mutation or a subscription. So what Hasura has done is it has generated GraphQL queries, mutations, and subscription for the model that we've created. So I'm going to start by inserting some data into that table. So I'm going to make use of mutation, which would call insert users one, and I'm going to give it an object. And we need to give values for ID, which will be of value 1, let's say, and name, which would have a value, let's say my name Praveen, and the created at and the last seen values have default values, so we don't need to specifically give any values to them. And we need to get back some data from the mutation. So I'm going to get back the ID again once the insert is done. I'm going to click on play now, and this is going to execute a mutation, and we've gotten back the data that we've inserted. Now let's query the data that we have inserted. So I'm going to make use of query, which will contact the users table, and I'm going to fetch the columns like the ID, name, created at, and the last seen column. I'm going to click on play now, and this is going to give us data from the users table. And you can see that the ID and name values that we've inserted comes in. The created at had a default value, and that has been inserted. The last seen has a null value, so it comes back as null from the database. All right, let's go to the data tab and look at the users table. This shows the rows that we have inserted. We've inserted the user row through the GraphQL mutation, and this appears over here, and you can keep inserting more rows to the interface or use the GraphQL API. So think of it as a manager to your Postgres schema and managing data through that. Now, as a next step, I'm going to create another table called to-dos. So this time around, I'm going to click on create table, and I'm going to create a table called to-dos, which will have a ID, which will be of type integer auto incremented, and the to-do will have like a title of type text. And there are a couple of Boolean flags that we need to take care of in the to-dos table. The first one would be whether it's a public to-do or a private to-do. And I'm going to say Boolean for this. And the next one would be whether the to-do is completed. So that will be another Boolean. And we have a couple of frequently used columns. So should be created at. And the last column would be the user ID. So we need to map which user has created this particular to-do. So we're going to map that. And finally, we need to select the primary key for the table. So this would be the ID column of the to-dos table. And finally, clicking on add table, we will have the APIs generated for the to-dos table. So let's go ahead and test the APIs that have been generated for this. And I'm going to start with a mutation. So let's say insert to-dos one followed by an object, and I can insert some values for these. So I'm going to start off by saying is completed being false and is public being false, making it a private to-do. And I'm going to say title. So in the title, I'm going to give a value my first to-do. And for the user ID column, I'm going to give it the ID one that the user that we created in the previous mutation for the users table. And I'm going to return back the ID of the to-do, which will be auto-generated by the database. So I'm going to click on play now. All right, now we've gotten back the data for the ID for the to-do that has been inserted. Now let's query back this data through the GraphQL query. So I'm going to say to-dos and followed by the columns of that table. So I'm going to make use of all the columns. So I'm going to follow it up with created at. I'm going to click on play. And we've gotten back the response from the DB. All right, so now we've tested both queries and mutations. Now the next step is to test out subscriptions. So Hasura gives you instant GraphQL subscriptions out of the box for the data models that you create. So for the to-dos table and the users table, we'll have subscription enabled automatically. We can test this out by using the subscription query and making the call to the users table. I have the ID and I have the name and the created at and the last seen columns, right? I'm going to click on play and we will have the data of the users over here. So in another tab, I'm going to make use of an insert. So insert a new user and then come back to this tab to see if the new user is appearing over here, right? So I'm going to head to the users table, click on insert row, add the second user and give it the name second user and click on save. So once this data is saved, if we go back to the subscription, we see that the second user now appears on the response and the subscription is still running actively, right? So this is subscription APIs automatically generated for all the data models that we create. Next up, we look at relationships. So we have created to-dos table and the users table, but we have not linked them through the relationship that we can create, right? If you go to the to-dos table, we have the user underscore ID column that we created, which would ideally be a value of the user's ID column. So I'm going to establish like a foreign key, which is a Postgres constraint to ensure that the value of the to-dos user ID is actually equal to the user's ID column. Let's choose the reference table as users and choose the from column as the user ID, followed by the to column as the ID. So what we are doing here is we are establishing a constraint for the to-dos user ID column to have this particular mapping. I'm going to click on save. Now the foreign key has been saved Let's head to the relationships tab to see what are the options available now. So we have a couple of relationships type. There is an object relationship and there is an array relationship. The object relationship lets you get data on a one-to-one mapping. The array relationship lets you get data on a one-to-many mapping. Now, each to-do is created by one user. So we are going to make use of the object relationship, and Hasura is able to suggest you an object relationship based on the foreign key setup that has been defined, right? And I'm going to click on add and make use of the relationship name called user. Click on save. Now, what this means is that I'll be able to start querying the to-dos table and also get the data of the user in the same query. So let's test that out by going to the API, make a query to the to-dos table, forward the ID, title, and also the user. So in the same query, we are making a join of data between the to-do ID and the user who created it, and we're just basically fetching the data of the user as well in the nested form. So we get back the response in the same query format that we asked for. And this is what is relationships. And if we go to data and go to the users table, we can see that there is an array relationship that can be created to fetch the list of to-dos that each user has created. I'm clicking on relationships, and we can see that there is a suggested array relationship to create, and I can click on save to create an array relationship from users table to the to-dos table. So one user can have multiple to-dos, and to be able to query that in the same GraphQL API, we can establish this relationship which will let you do that. Great. So now we've created relationships. Now the next step is to leverage what Postgres gives you. And for the next feature, we want to be able to query the list of online users in the database. And for that, we have a column called last_seen in the users table. So using the timestamp of the last_seen value, we're going to make a view which lets us compute who's currently online in the last 30 seconds of time, right? We can make use of the SQL tab to execute any raw SQL statements which will be executed against the database. So I'm going to create this view called online_users, which actually selects the columns from the users table with the var clause. And the var clause says that the user's last seen value should be greater than equal to the last 30-second time interval. So if it is there, then the view would actually give back the user's data. And I'm going to track this view so that Hasura can generate a GraphQL API for this. I'm going to click on run, and this create or replace view statement would be executed on the Postgres database. Now let's go back to data, and we have the online_users view that we have just created. Currently, we don't have any data because there's no user which has a last seen value in the last 30-second interval. So let's test that out by modifying the value of a user's last seen. I'm going to edit the user 1 to have the current last seen value. I'm going to click on save. Now head back to the online users view to see the user who's online right now. Now this will give us the last seen value of the user, but we don't know which user is currently online. So to fetch the information of the user, I'm going to make use of a relationship that I'm going to create manually. So each online user's ID value is equal to the ID of the user. So I'm going to create an object relationship to say user, and the reference table would be the users table. The column mapping would be the ID column of this view to the ID column of the users table. I'm going to click on save. Now the object relationship has been created. Now let's test this by making a subscription call to this online users view to get the list of online users at any particular time, right? And I'm going to make use of the users table to edit the last seen value again so that we get the data back from the database. And I'm going to edit my own value again to give the latest timestamp. And once we save this value, we can go to the API to test this out. I'm going to head to the API and make a call to subscription for the online users, which would have ID, the last seen, and the user table as well. Click on play, and we'll get the value of the ID and the last seen timestamp, followed by the user details of the ID and the name of the user, right? So far, we looked at generating the GraphQL APIs for the data models that we created. Now, the next step is to set up some authorization rules so that we will restrict access to all of these models. Head to the data tab and we will see how to add permissions to all of these data models, right? Let's get started with the to-dos table and head to the permissions tab. We'll create a new role called user, which will have an insert permission with a custom check. We need to ensure that the user who's inserting the to-do is mapped with the right user ID, and hence the permission check would be to check if the user ID is equal to the X Hasura user ID. Here, the X Hasura user ID is the session variable that Hasura will automatically substitute from the claims of the auth token. And next up would be the columns that we need to select for allowing this permission. I'll have permission for the title to be inserted and the public value of to do. Let's click on save permissions. Now the insert permission for user has been defined. Next up, we'll go to select. For selecting a to-do, we have to make a custom check, and this would be a Boolean condition because there are two conditions to ensure whether the user is selecting the right to-do. If the to-do is a public to-do, then we should let the user access it. So the condition would be is public equals to true. And the other condition is if the user ID matches the X Hasura user ID column. So if either of these condition is satisfied, then we should let the user access the to-do records. And on the column select permissions, we will give access to all the columns that are required for this table. I'm going to click on save permissions and we'll be done with the select permissions for to-dos table. Then the next permission would be for update, and I'm going to select the same custom check as insert, where we'll be checking the user ID column is equal to the X Hasura user ID session variable. And on the columns list, I'm going to allow only is completed to be updated, and everything else will remain unchecked. I'll click on save permissions to wrap up the permissions for update. Finally, the delete permission would be the same as the insert, where we'll check if the user ID belongs to the X Hasura user ID. If so, let them delete the to-do that they created. And I'm going to click on save permissions. Now the delete permissions have been updated as well for the to-dos table. Next up, we'll set up permissions for the users table. So I'm going to head to the users table and click on the permissions tab over here. The insert of the user is assumed to be done through a authentication provider where once a sign up happens, the user will be inserted into the database, and hence I'm not going to edit the insert permission. But for select, I'm going to say without any checks, because anybody who's logged into this application should be able to access the users of this application. So I'm going to allow the ID and name columns of the users table, and I'm going to click on save permissions. Next up for update, I'm going to have a custom check which checks the ID of the users table to be equal to the access user ID. So the user should be able to edit their own records, and this condition will ensure that they are able to only edit their own records. Next up, we'll let them update only the last seen column. So I'm going to toggle the last seen column over here and click on save permissions. And again, for delete, we assume that the insert and delete of the user will be taken care by the authentication provider based on sign up and log out and deletion of accounts. Finally, I'm going to set up permissions for the online users view, which will have an open access for anybody who's logged in. So the select permission for the user role will have, without any checks, both the ID and the last seen columns. And I'll click on save permissions to wrap up the authorization layer of this application backend. Now let's quickly recap what we have done so far. We deployed Hasura and connected it to a Postgres database on Heroku. We then created some tables and tried out some GraphQL queries, mutations, and subscriptions. We created a Postgres view for data transformation use case for online users. We also set up some relationships between the to-dos table and the users table. Then finally, we had set up some role-based permissions to secure our app. And that's it for this video. For more support, learn more at our learning portal at hasura.io/learn. You can also join our Discord channel where we have thousands of community members actively engaging and participating in discussions. You can also follow us on Twitter for the latest product announcements. I hope this video was pretty useful for you to quickly get started with Hasura. Thanks for joining in.